Hi students. So in our previous video, we have started your activities or triangle activity. So we'll continue with the same texture part of it. We're gonna see why we have to set this texture. The importance of soil texture is for us to understand the water holding capacity of the soil. For example, if a soil contains a lot of sand, so the water holding capacity will be low. That means the nutrient retention is low, while drainage is very high, permeability is very high, and soil workability is very low. If the soil contains a lot of clay and silt, even portion of sand, silt, and clay, that means low is alright. So the water holding capacity is very high. Permeability is also high. Soil workability. Soil workability means whether we can do agriculture, we can mold the soil, we can do anything with that soil. Ability of plants to grow, yes, very high. Okay, this is why we have to study soil texture. These are the 4 things to understand, to identify these 4 things. Alright, so we have completed the soil texture. Remember, soil texture means the composition, the proportion of sand, silt, and clay soil. Now soil structure, as we already mentioned in the previous video, and also in the chapter 1, the last part, when we touch on soil horizon, soil profile, we explain the soil structure. So here again, soil structure means the arrangement of soil particles. Okay, here in the notes it's mentioned, refer to the arrangement of soil separates into units called soil aggregates. And aggregates possesses solids and pore spaces. Yes, for the level we will check or we will look into these 6 types of structure. Granular. Last chapter 1, I give an example on rice or on sugar or salt that is very in grain form. That's why we call it as granular. If in aggregate means small granules combined and make a piece like a ball. That's what we call as aggregates. Some soil structures are blocky, some in columnar or prismatic. Columnar, prismatic, almost same, but only columnar at the top of it is like the soil. Okay, you can see here. Columnar and prismatic, and the top here like it's wearing a cap, right? And this is prismatic, means flat. Both the same, just on top of it is different. So we have plates. Plates make like wood. They have plates, layers under these layers. These are common soil structures that we can find in Malaysia as well. These 6 types. And remember, we have to focus on this. We will not come out on the test and simply list down 3 common soil structures that are available in Malaysia, or that common in Malaysia not available. So common in Malaysia, or 5, 6 list down. So very easy. It's granular, platy, blocky, and columnar, prismatic, massive. It's easy to list down these things. Alright, soil structure contributing factors. Why we have so much variance in soil structure? Well, the soil texture is only contains at all, although the structure is different, but in terms of texture, the composition of sand, silt, clay will be same. Only these 3 things. So why we have so many structures? Because of climate. changes in climate, wetting and drying seasons. If it's so dry, example we take Middle East countries like right? Middle East countries. Always very hot, right? So what we can find there? The soil type is sandy. That means a granular form. If it's always wet, like Holland, Holland, right? Netherlands, a lot of soil in Holland is we call as spotland. What is spotland? Spotland means you remove the water, so that the soil is beneath, under the sea. So what they do, they pump out the water and they build big tanks. And they do agriculture on that. The soil we call it spotted soils. Those kind of soils are very, what we call is plates. It's with plates and some will be like rocky. And freezing and thawing. The first factor is factors, right? Why a lot of the variations of structure is affected by climate change, it's affected by freezing and thawing. Freezing and thawing means freezing means membeku, salju membeku. Thawing means it's menjadi normal balik. Ice menjadi air. Defrost. Thawing means defrost. When freeze back, defrost, freeze back. So continuously it changes the structure. Microorganism activities. They aid in the decay of methods. This one, this is increase the organic materials, organic matters in salts. The top layer will look as in granular form. Easily will look like granular. And plant roots and soil elements. Okay, we did two areas. One is we have upland and grasses. The other one is bare soil. So the bare soil normally, if they have plants, okay, when they have plants, those plants will go inside and it might form aggregates or it might form platy layers, blocky layers. But when the soil is very bad, nothing on topsoil, it ends up like prismatic or column. Doesn't have a lot of spaces in between soil particles. And here you can see here low permeability, moderate permeability means a lot of pore spaces, micropores and macropores here. High, moderate, can go in, cannot go in, the water can penetrate in. If platy means is very low, massive, low. Community, of course, massive means if you still remember what we did in chapter 1, the part 3, when we talk about soil profile, soil horizon, touch on the sea horizon and under the sea horizon, what we have at the horizon, both are massive blocks. So these are the 4 factors that contributing contributing to the formation of different soil structure. Soil density, very quick. Finish it up. Soil density. Density means ketepatan, isi mass or volume, which is isi padat. Measurement of how tightly soil particles are pressed together. So if question come out in exam, if you write the formula also enough, you can get points, you can get marks. Particles and bulk density. There are 2 types of densities in soil. Okay, bulk density or particle density. And okay, you can see what's the difference between these 2 pictures. One is got a lot of macropores. The other one only contains micropores. Okay, then this is a compressed soil. The soil is already compressed. This one it's normal soil, haven't compressed yet. So this is bad density. Okay. If the soil haven't compressed yet, this is bad density. Once you compress, you remove the micropores and micropores. So when we do the calculation of density, we want to show the particle density. This one actually to show whether which soil contains high density and a lot of more spaces. For sure, from the picture itself, you will know this got a lot of pore spaces, less pore spaces. So when you have more pore spaces like this, when we have more pore spaces, this is low bulk density. This is very high bulk density. The difference between these two, when we do calculation for density, the mass will be same. Mass means berat. G same. G same itu adalah sama. Kalau saya ambil tanah 1 kilo untuk calculate bulk density ke particle density 1 kilo, but the easy value or the volume when we compress, if 1 kilo means 1 meter times 1 meter, sorry. 1 cm. So you get about roughly about example. I give every 10 cm. Roughly you get about 1 kilo. So I think that will be easy. Tanah dalam satu cube. Say a cube. You take a cube. So 1 cm. 10 cm. You fill up soil about 1 kilo. So 1 kilo divided by 10 times 10 cube, that's 1000. So we will get the bulk density. But to calculate the particle density, you will compress the soil. Once you compress the space is lost, so the volume will be reduced. Once the volume reduced, so the density will be higher. So we will calculate density. See, this example you can check here. It's the same thing. Just to compare what is between density and particle density, the only changes will be the volume. The mass is same. Remember, only the changes are in the volume. Okay, porosity. Porosity means the pore spaces. Yeah, macropores and also micropores. The spaces between particles is called pore spaces. Pore spaces determine the amount of water that a given volume of soil can hold. Normally, water will be held here and air, and water will be stuck here. Okay, we have to move on slides. Color factors. Colors is the last part for physical properties of soil. So basically we have 4 types of soil. 4 colors. 4 colors, that is red, brown, white, and black. And the factors that affect these colors are organic material, minerals, and the soil contains a lot of organic materials. So in black in color, it contains minerals. It depends on the type of mineral. Maybe red in color, it contains calcium or calcium will be white in color. If it contains normal general minerals like potassium, phosphorus, so non-minerals will be brown in color. And the nature and problem of islands and moisture content drainage.